Lesson 28-3, multiplying and dividing rational expressions. Learning targets: multiply rational expressions, divide rational expressions. Suggested learning strategies: note-taking and close reading. To multiply rational expressions, first factor the numerator and the denominator of each expression, then divide out any common factors, then simplify if possible. Now, this is a way of multiplying that I kind of wish everybody is taught in elementary school. So I'm going to do an example, not example A, but I'm just going to say 8 over 10 times 5 over 16. Pretty easy multiplication. If we think of this instead of multiplying straight across and then simplifying, or even what we talked about, how you simplify before you multiply, the way we want to kind of think about doing this to relate to polynomials is we want to break down every number to its prime factors. So 8 would be 2 times 2 times 2, and 10 would be 2 times 5, and then 5 would just be 5. 16 would be 2 times 2 times 2 times 2, okay? And then now all we have to do is go ahead and cancel anything from the top with anything from the bottom. Okay, so we're going to cancel a 2 there, a 2 there, a 2 there, a 5 there. And so everything cancels on the top. So that means the top is going to end up being 1 because everything cancels out. And then the bottom is going to be whatever's left over, and it's just 2 times 2. So 2 times 2 is 4. So the answer to that is 1 over 4. That's the idea of what we're going to be doing today. We're gonna take our polynomials, we're gonna break them down into factors, and then we're gonna cancel whatever factors we can. Okay, so let's go ahead and look at example A. 2x minus 4 over x squared minus 1 times 3x plus 3 over x to the third, or is it x squared? X squared minus 2x. And so what we want to do is we want to look at every individual polynomial, and we're going to go ahead and see if we can't factor that. And so we look at 2x minus 4. 2x minus 4, we can factor out a greatest common factor of 2. So that means we're going to factor out the 2, and it's going to leave us with 2x divided by 2 is just x, and 4 divided by 2 is 2. So it's going to leave us with those factors there. Then we're going to factor x squared minus 1. And x squared minus 1, there's no greatest common factor that we can factor out. The greatest common factor is 1. But it is a special product. This is a special product. That's always the second thing we look for. Is it a special product? This one is the difference of 2 squares. So we're going to go ahead and write that out. It's going to be x plus 1 and x minus 1. Now, if I'm not sure how to get these numbers that I'm writing down, then you want to make sure you go back and review or come to tutoring, and we can take a look at it a little bit closer. So now we're going to look at the 3x plus 3. 3x plus 3 has a greatest common factor of 3. So I can factor the 3 out. And that's going to leave me with 3x divided by 3 is just x. And 3 divided by 3 is 1. And then, of course, the last one is x squared minus 2x. And first thing we look for is the greatest common factor. In this case, the greatest common factor, they both have an x. So the greatest common factor is x. So we go ahead and divide those out. X squared divided by x is just x, because x times x is x squared. And negative 2x divided by x is just negative 2. Okay, so now we've gone through and we've taken every different place and we've factored them out to where we can't factor them anymore. And the next step is just go across the top, looking at all the factors on the top and see whether they can cancel anything on the bottom. And so we're going to do that. We're going to go ahead and we're going to say 2. Well, there's no 2's down here that's by itself. And then we have x minus 2. Well, x minus 2, there's one here and there's one there. So I can cancel out the x minus 2. And then we have a 3. Well, there's no 3's by itself. And then the next one is x plus 1, and we can see we can cancel an x plus 1 down right here. And then we multiply whatever's left over. We have 2 times 3, which is 6. And then we have an x and an x minus 1. So we can go ahead and put that x times x minus 1. That is the answer. Are there any questions? Remember, thumbs up if you got it. Well, you can do it that way too, I guess. Or the keyboard thumbs up. Of course, if you have any questions, a little clap. So it sounds good. So that one was pretty straightforward. So let's go ahead and we'll look at the try these here. All right, so we'll do try these A. Y squared plus 5y plus 6, all that over y plus 2 times y over 2y plus 6. So, okay, so we'll go ahead and we'll go ahead and factor each of the different positions here. So we'll start off with the y squared minus 5y plus 6. And the first thing we want to do is look and see, hey, is there a greatest common factor greater than 1 that we can factor out? And in this case, there is not. And then we look to see whether there's a special product. If it's a trinomial, the only thing it could be would be a perfect square trinomial. Y squared is a perfect square, but 6 is not. So therefore, it is not a special product. So we go ahead and just try to factor it. So we know it's going to be a couple binomial factors, and they're both going to be y squared, because y times y is y squared when we FOIL it back. And then, of course, we look at this sign right here. And that tells me it's a plus, which tells me the signs are the same. And this one tells me what they are. They're both plus signs. All right, and then now what we're looking for is factors of 3 that when we add them together, we get 5. And of course, that's going to be 2 times 3. And then now we have our y plus 2. And that one cannot be factored any further. And then we have a y on here. And again, I can't factor that out either. So the next one is 2y plus 6. And so I got to look and see whether there's a greatest common factor. And the greatest common factor that I have available here, of course, is 2. 2y divided by 2 is just y. And 6 divided by 2, of course, is 3. So now that I have factored everything out, now I look to see what I can cancel. And I always just go across the top to see if there's anything below. So I have my y plus 2, and I look on the bottom to see if there's a y plus 2, and there is right below it there. And it can be anywhere on the bottom here. And then I have my y plus 3, and of course I have a y plus 3 down here on the bottom on the other side. And I have a y. Well, I don't have a y by itself. And so I've looked at every number on the top. So my answer is just what's left over. So the only thing left over on the top is a y. And the only thing left over on the bottom is a 2. So my answer, of course, is y over 2. Let's look at the try these B. 2x plus 2 over x squared minus 16 times x squared minus 5x plus 4 over 4x squared minus 4. 2x plus 2, and that has a greatest common factor of 2. And that, of course, is going to leave me with 2x divided by 2 is just x, and 2 divided by 2 is 1. Then we have our x squared minus 6. X squared minus 6, it does not have a greatest common factor, but it is a difference of squares. And we know that a difference of squares is going to simplify to x minus 4, x plus 4. We're going to look at the x squared minus 5x plus 4. First thing we want to do is we want to look to see whether or not it has a greatest common factor that can be factored out. And because this first term is a 1, remember the greatest common factor cannot be any higher than the lowest coefficient. So greatest common factor is going to be 1. Next thing we look to see whether it's a special product. We might think it is. The first number is a perfect square. The x squared is a perfect square. The 4 is a perfect square. But the 5 doesn't fit the pattern, because normally we would say, well, okay, that's going to be x and 2 if it was a perfect square trinomial, and then 2 doubled would be a 4, so the middle number would have to be a 4. So this is not a special product. It looks like it might be, but it's actually not. And so we just have to factor it in the usual way. So we go ahead and we set up our 2 binomials. And they're going to both start off with x because x times x is x squared. The first thing here we look at is the second sign. That means they're going to be the same. And the first sign tells me what they are. So they're going to be both x minuses. And so we're looking for factors of 4 that when we add them together, we get 5. So those would be 4 and 1. And so 4 and 1. If you're ever not sure, remember, you can always FOIL these back. X times x is x squared. X times negative 1 is negative 1x. Negative 4 times x is negative 4x. Negative 1x and negative 4x is negative 5x. And then negative 4 times negative 1 is positive 4. So we can always FOIL it back if we needed to double check. The last one is 4x squared. 4x squared minus 4. And so the first thing we want to do is see if there's a greatest common factor we can factor out. And there is. We can factor out a 4. Okay, we can factor out a 4. And that's going to leave me with x squared minus 4. 4 times x squared minus 1. I'm sorry. And that x squared minus 1, that is a difference of squares. That is a difference of squares. Okay, so that means it's going to be x plus 1, x minus 1. And now all we have to do is simplify. So first thing we do is we look at 2 and say, well, 2 simplify with anything that, down on the bottom? No, 2 will simplify with 4, because remember, 4 is just 2 times 2. Okay, so 4 will simplify with that. And so it's going to leave me with a 2 on the bottom. 2 on the bottom. X plus 1 simplifies with x plus 1. X minus 4 simplifies with x minus 4. And x minus 1 simplifies with x minus 1. So that's going to leave me with a 1 on the top, 2, x plus 4. And that's going to be my answer. Now, example B is division. So we're going to start off with the problem. It's going to be x squared minus 5x plus 6 over x squared minus 9 divided by 2x minus 4 over x squared plus 2x minus 3. And I would recommend you take care of the keep, change, flip immediately before you do anything else. So we're going to keep the first fraction. So that's going to be x squared minus 5x plus 6 over x squared minus 9. Then I'm going to change it to multiplication, and then I'm going to flip them. So I'm going to put the x squared plus 2x minus 7 over the 2x minus 4. Okay. All right, so once I have that, now it's a multiplication problem like we did just a moment ago. So we go through and we look at these and we say, okay, is there a greatest common factor I can factor out here? We say, no, there's not. So it's not a special product. So we're going to go ahead and factor it in the usual way. So that's going to be x. Looking at this one here, that tells me the signs are the same. Looking at the front sign, it tells me they're both negative. So we're looking for factors of 6 that when we add them together, we get 5. So of course, that's going to be 2 and 3. X squared minus 9. We check for a greatest common factor. Greatest common factor is 1, so we can't factor anything out. And so we look closely. It's a difference of squares. So we know since it's a difference of squares, that's going to be x plus 3, x minus 3. Those 3's did not come out very well.
Mr. Kenner?
Yes.
You put on the second equation, and in the book it says -3.
And so it does. Okay, so I couldn't read my original 3 over there, I think. Thank you for telling me that before we got to it. So I appreciate that.
I was like, wait a minute.
Well, that's one reason why I like you guys being here, so that you can keep me honest. Okay? Because I'm only allowed a certain number of mistakes. I think I've well exceeded those. Anyway, thank you for telling me that. All right, so we're working on this one down here. This is the x squared minus 3, or x squared minus 9, which is a difference of two squares, or difference of squares. And so it's going to be x plus 3, x minus 3. And then we're going to do the next one, which is the one we had in question here. X squared plus 2x minus 3. There's no greatest common factor other than 1, so I can't factor anything out. It is not a difference of squares because this 3 is not a perfect square. All right, so we're going to go ahead and just factor it in the usual way. It's going to be x and x, because x times x is x squared. And then now we look at the back sign, that's negatives. That tells me one of these is going to be a plus, the other one's going to be a minus. And the front sign tells me what the larger factor gets, because I want my answer to be positive, and I'm subtracting numbers, the larger one is going to have to be positive. So because my signs are different, I'm looking at factors of 3, that when I subtract them, I get 2, and of course that's 3 and 1. But because I want it to be positive, the 3 becomes a positive number and the 1 is the negative. All right, the last one we need to work with is this 2x minus 4. 2x minus 4 has a greatest common factor of 2 that I can factor out. And then that's going to leave me with, well, 2x divided by 2 is just x. And negative 4 divided by 2 is negative 2. And again, you can always double check that if you think about factoring back in. 2 times x is 2x, and 2 times negative 2 is negative 4. So we can always double check these as we go if we need to. Now I'm going to go across the top and factor out what I can. So I have here, I have an x minus 2, and I'm going to factor that out with this x minus 2 here. I have an x minus 3. I'm going to factor that out with the x minus 3 there. I have an x plus 3. I'm going to factor that out with the x plus 3. And my x minus 1, I do not have an x minus 1 on the bottom. So whatever's left over is we multiply together, and that's our answer. So what we have left over is we have an x minus 1 on the top, and we have a 2 on the bottom. Notice if we only have one grouping left over, we don't have to put it in parentheses. To the try these be w squared minus 2w minus 3 over w squared minus 6w plus 9 divided by 5 over w minus 3. All right, so now we do our keep, change, flip. So we're going to keep the first one, and then we're going to change it from division to multiplication, and we're going to put the w minus 3 on the top and the 5 on the bottom. We're just going to flip these. So we're going to do the w squared minus 2w minus 3. And the first thing we notice is there is no greatest common factor other than 1, so nothing that we can factor out. 3 is not a perfect square, so there's not a perfect square trinomial. So we're going to just go ahead and factor this in the usual way. So we know in order to get w squared, we have to have a w here and a w here. We look at the second sign that tells me the signs are different. The first sign tells me what the larger of the two factors are going to be. And right now what I'm trying to do is I'm trying to find factors of 3 that when we subtract them, we get 2. And so that's 3 and 1. 3 minus 1 is 2. And because we want our answer to be negative, then the 3 goes where the negative is, and the 1 goes where the positive. All right, so now we have our w squared minus 6w plus 9. And this one has no greatest common factor other than 1. So I can't factor anything out. This one might be a perfect square trinomial though. W squared is a perfect square, 9 is a perfect square. And so we think about, well, the factors there would be w and 3. So we multiply those together. So w times 3 is 3w, and if I double that, I get 6. So this is a perfect square trinomial. So I could write this as just, well, w minus 3 squared. I could write it like that. But because we're going to be canceling things out, I'm just going to go ahead and write it out. And so that was just following the formula chart for the perfect square trinomial. If this is minus, remember that they number in the thing inside has. All right, and then we have our w minus 3 over here that it cannot be factored any further, and we have our 5. All right, so now it's time for me to cancel. Now remember, if this is by itself, it doesn't have to be in parentheses. Just keep in mind that the numerator and the denominator are kind of groups in themselves. So now I can go ahead and cancel out. So I have a w plus 1. I look on the bottom, I do not see a w plus 1. I have a w minus 3, though, which I can cancel. I have another w minus 3, which I can cancel. And so my answer is going to be the w plus 1, all that over 5. Okay, so let's go ahead and do B. 3xy over 3x squared minus 12 divided by xy plus y over x squared minus 3x plus 2. 3xy over 3x squared minus 12. That one did not change. We're, of course, keeping that. All right, we're going to change it to multiplication. And we're going to flip these. X squared plus 3x plus 2. All that over xy plus y. All right, so we'll go ahead and we'll factor these to individual factors. And we have a 3xy, and there's nothing there that can be factored out. So that's just going to stay 3xy. Now the 3x squared minus 12, we can factor out a greatest common factor of 3. So that's going to be 3 on the outside. And then 3x squared divided by 3 is just x squared. And then 12 divided by 3 is just 4. And as I look at that, I'm noticing that the x squared minus 4 is a difference of 2 squares. It's a difference of 2 squares. So it's x squared minus 4. It's a difference of 2 squares. And so I'm going to go ahead and erase it because I can here. And that's going to be x plus 2, x minus 2. Okay, that's what that becomes. Okay, and then we're going to do the x squared plus 3x plus 2. And that one is does not have a greatest common factor. It is not a special product because it's a trinomial and 2 is not a perfect square. And so we just factor it in the usual way. So the second sign tells me that the signs are going to be the same. First one tells me that they're both plus signs. All right, so what I'm doing is I'm looking for factors of 2 that when you add them together, you get 3. And of course, that's going to be 2. And now the last one I'm looking at is xy plus y has a greatest common factor of y. So xy divided by y is just x. Y over y, or y divided by y, is just 1. Now remember, a lot of people want to accidentally put just x in there. Remember, y over y, or y divided by y, is 1. All right, the next thing we're going to do is we're going to cancel out. So we look and we say, okay, do I have a 3 down here? Well, I do have a 3 down here, as a matter of fact. So I'm going to cancel those out. Isn't that a pretty color? And do I have an x down here? Well, not by itself, I don't. Do I have a y down here? Well, absolutely, I sure do. So I can cancel out the y's. Do I have an x plus 2? Well, I do. I have an x plus 2 right there. And do I have an x plus 1? Well, sure, an x plus 1 right there. So we can see we've gone ahead and canceled out. We look, the only thing left on the top is an x. And on the bottom, the only thing left is x minus 2. Let's go ahead and move to check your understanding. Critique the reasoning of others. A student was asked to divide the rational expressions shown below. Examine the student's solution and then identify the correct the error. Okay, the problem was x squared minus 9 over 3x divided by x plus 3 over x minus 3. And then they said that equals to 3a over 2, or a squared minus 9 times a plus 3 over a minus 3. And that would then go on to equal 3a over x plus 3 x minus 3 times x plus 3 over or a plus 3 over a minus 3. They canceled out the a plus 3 on both the top and the bottom and left them with 3a over a minus 3 squared. Okay, and then again, I wrote it that way because the a minus 3 is written there twice, and you can write it as that being squared. All right, so there is a mistake here, obviously. And who can tell me what the mistake is? Anybody? Nobody?
They flipped the first one.
All right, yeah, it looks like they flipped the first term instead of flipping the second term. All right, so item number 2. What is the quotient when 2x plus 6 over x plus 5 is divided by 2 times, or 2 divided by x plus 5, or 2 over x plus 5. All right, so basically it's just asking us to divide these two numbers, and it's already got them in the right order. So it's basically that problem right there. So it's just a matter of doing the work. So we'll start off with the first term. We'll keep the first rational expression, and then we'll change it from division to multiplication, and then we'll flip the second rational expression, and then we'll just go ahead and multiply. But the way we want you to multiply is to factor each binomial, if you can. And so it's 2x plus 6. Greatest common factor there is 2. So 2x divided by 2 is x, and 6 divided by 2 is 3. X plus 5 cannot be simplified. X plus 5 cannot be simplified. Okay, and then it's just a matter of canceling out. 2 cancels with the 2. The x plus 5 cancels with the x plus 5. That leaves you with just the answer of x plus 3. Now remember, if you have any questions, you can always come into tutoring, or you could text me anytime. I'm going to leave the rest of the problems, the practice problems, for you to do as homework. And that's going to conclude this video.